Today we're going to learn about how to solder. The second type of soldering you can see here is surface to surface. The Cornell notes are linked underneath. Our essential question for this soldering type is describe how surface to surface soldering might be beneficial to understand when creating jewelry. The learning targets for the soldering process are: I understand each type of soldering and can demonstrate each technique. I understand all safety protocols to protect my body and others during the soldering process. And I will use the solder to create a permanent solder connection on my current jewelry piece. There are 4 different basic types of soldering you will learn about in this video presentation. They are edge to surface to surface, and ring and bail. We will discuss what they mean and how to do them shortly. There are general soldering tips at the beginning of each presentation. As we move along from one soldering type to the next, we will skip past the general tips to make the start of class go a bit faster, but each video will include them just in case you arrive in class at an unusual time. If that is the case, the general presentation ends at slide 26 in each Google slideshow, and the video timeline would start with specific tips at 9 minutes and 45 seconds. The general tips are very important and very helpful, so you should watch them at least one time. You can watch the video here and complete each set of Cornell notes as we go through each type of solder. It's highly recommended that you take some notes so that you remember different things, and remember, you can always use the notes on the safety and tools quizzes we have later. As we start to talk about soldering, there will be some general soldering information we'll talk about first because it applies to all solder types no matter what type of soldering you're trying to create. First of all, for you science geeks out there, we are going to talk about the crystalline structure of metal. As you can see, there are different types. The ones on the left are the most malleable or bendable, and we will be working with those in class. What you need to realize about metal is that it's a substance that has more or less a shiny appearance, is a good conductor of electricity and heat, and can be melted, and are usually capable of being shaped. If you think about solids, liquids, and gases, you realize solids are the most dense in terms of anatomical structure, liquids are a bit farther apart, and gases are the most far apart. When metal is heated, it will eventually become liquid. Solder is a substance that melts before the metal does, allowing the solder to fill the spaces between the metal particles, as you can see here. When heat is removed from the solder solidifies, creating a permanent bond between metals at room temperature. When you solder, you have to put 2 pieces of metal together so there are no gaps. You can see the solder on top of the metal being red in this diagram. As the crystals expand, the solder flows between the crystalline metal structure by capillary action, and when heat is removed, the structure becomes solid, with the solder creating a bond between the 2 metals. Now we need to talk a bit about soldering safety. It's important to wear safety glasses and tie long hair back when soldering. It's also extremely important to have the exhaust fan running to remove any gas from the soldering area from the room. In addition to tying your hair back, you really need to pay attention to where your body is when you're soldering. This person didn't do that and burnt his hair because he got too close to the open flame. Additionally, I want you to notice his burnt eyelashes because he wasn't wearing safety glasses either. Don't let that be you. You should already realize this from the science talk earlier, but this is not electrical soldering or soldering with a soldering iron. That will not work for jewelry, as the connection will eventually let go because the metal was not heated thoroughly enough to create a strong bond between the surfaces. When we solder, we will be using a torch that has 2 adjustment knobs on it. The red knob is for gas and should be turned on first. It should be then lit with the striker. Once there is a flame, the green air knob can adjust the flame to whatever you need for the process you are trying to complete. These knobs work the same way that Dremels do. Remember, leftsy-loosey, righty-tighty when you are looking down at the soldering knobs. The hottest part of the flame is the tip of the inner blue cone. When you are soldering, you want to have the tip of the blue cone on your piece in order for the process to work. This next slide shows differences in flames that you need to know for both soldering and annealing. The flame on the top is a very soft flame, like the flame you use to start the torch, but with a little air, it's good for drying flux to get pieces to stick together so placing the solder on your work is easier. The neutral flame you see in the middle is much larger and louder than the first type, but it's still a loose flame. This will be good for annealing. The last type is a tight cone flame, which is important for soldering because it creates the most heat and is a very specific shape so you can see where you're heating your work. Another substance that is absolutely needed for soldering is flux. If you don't use it, your work will not solder. Flux not only helps the solder flow, but prevents some fire scale while you are soldering. Flux has silica in it, which are tiny glass particles. This means that you need to be careful in the soldering area because there may be sharp parts from people picking their work up off the equipment when it's still hot. This would pull the glass created to a point which could cut you. Other general soldering tips are using the right size flame for what you are doing. Larger flames that are quite loud are good for soldering larger things like edge to surface or surface to surface samples, and often many pieces, and smaller flames are used for soldering smaller pieces like the ring and bail samples or your bezel wire. You also have to pay attention to where the flame is on your piece so the solder will flow where you want it to go, and so that you don't accidentally melt your piece. Pieces also have to be completely free of oil and dirt and fluxed in order to solder. This means once you've sanded your pieces, you should not touch them with your fingers, even though you may have just washed your hands. There are technically microscopic dirt and oil that you can't see that will prevent your work from soldering. The first person to solder each day should turn on the exhaust fan when we start working. Make sure you heat the piece evenly in concentric circles until the solder flows. Remove the heat so the solder solidifies. We will then quench or dunk the piece in water using the steel tweezers that are in the soldering booth. These tweezers should stay in the booth so they don't accidentally contaminate the pickle. One thing to note here is that as soon as you quench the piece, your work is no longer hot, so you don't need to carry it to the pickle with the tweezers. Fire scale is really the bane of the jeweler's existence when soldering or finishing work. Fire scale is a form of oxidation, like rust, that can be removed with acid that is in the pickle pot. You have to be careful as it can become permanent if you overheat your piece an extreme amount. A couple of other tips to avoid fire scale are using a hit and run technique, meaning that you keep the flame moving in concentric circles to avoid heating the metal too long in any given area. It's also important to use the right size flame so you get the work done quickly and use enough flux so the solder is able to flow when it melts. Once there is fire scale on a piece, the only way to remove it is with pickle. Again, pickle is an acid, so you need to use the copper tongs or the pre-drilled pickle containers to place your work in the pickle. Pickle does work at room temperature, but works better with heat. Remember to keep the pickle pot on low so it doesn't boil, and always put the cover back on the pickle when you're finished retrieving your piece. Remember, boiling pickle is noxious, meaning it will kill you if you inhale it, so we have to be really careful to ensure that doesn't happen. This is done by turning off the pickle at the end of the hour and making sure it's on low every time you are near it. A few other pickle tips you need to know are how to remove pickle ionization. If anyone uses a steel tweezers to get their piece out of the pickle, it will change the solution to an ionizing solution, meaning any piece in the pickle will develop a layer of copper on the surface as free radicals in the solution bond with the metal you place in it. To remove excess copper from your work, you will need to create a new batch of pickle. Then take 1 container of hydrogen peroxide and a plastic spoon of pickle in a separate container and place your piece in it. Check every 5 minutes or so because once the copper is removed, you should take your piece out of the solution. If this seems like too much work, you can always sand the copper off, but it takes a lot more effort. The equipment needed for surface-to-surface soldering are a tripod and wire mesh and the torch. This will hold both pieces. First, the top piece as it is being soldered, and then both pieces as they are being soldered together. This next slide is just a reminder that you need to make sure pieces are clean and totally flush, meaning they're totally together without any gaps, so that they solder. Now we are going to move on to the steps for surface-to-surface soldering. Take the two pieces from the teacher desk or counter. One piece should be larger than the other, as you can notice in the bottom middle part of this slide. First, you have to flatten the pieces. This next slide is just a reminder that you need to make sure pieces are clean and totally flush, meaning they're totally together without any gaps, so that they solder. First, you have to flatten the pieces. Although you'll be taking the pieces from a box near the teacher desk, they may not be totally flat due to being cut quickly, so you'll need to take care of that with a rawhide mallet and an anvil. The next thing you should do is stamp your initials in the pieces so you and your instructor can identify your work. You may have to re-flatten the pieces after you do this. Look at these pieces carefully to make sure the entire surfaces touch. Remember, as you're hammering the pieces, you need to make sure the entire surfaces touch, like this image in the top right. There should be no gaps. The one on the bottom here is showing you that there's gaps between the pieces. You may have to flatten the pieces after you do this. Look at these pieces carefully to make sure the entire surfaces touch, like the example that's in the upper right. Once the pieces are flat, you need to sand the surfaces of one side of each piece. You are basically cleaning it so the solder will work. Doing a sloppy job here will create a headache later because the piece will not solder. Remember, once you sand the pieces, you shouldn't touch them with your fingers. I normally suggest using the top of your tool tin to carry pieces to the soldering area as it makes the process easier. Once you're in the soldering area, pick up the pieces with the steel tweezers and flux all the surfaces of the smaller piece. You can sand and cut strips of solder. The example in the upper right shows cutting the solder like fingers and then cutting small squares out of it. Then position the smaller piece on the tripod with the sanded side up and put pieces of sanded and cut solder all the way around the perimeter of the piece. Solder melts easiest when it's cut into smaller pieces, so if you think putting one larger piece in the solder helps you, you are really just going to create a potential fire scale problem later. One thing to note about solder is that you will be given hard solder for these pieces, so you understand how long it will take to make a solder work. I need you to notice that the solders melt at different temperatures because we will be using different temperatures for different processes that we do. While we are creating samples right now with one type of solder, you will have multiple solders in most of the work you do. This means you need to understand you should always start with hard because it melts at the highest temperature and then move to the lower melting point solders as you need to. If you have 4 or more solder seams in a piece, which is common, you will have to problem solve on how to create and combine steps to make that work. The instructor can help you check that and reorder them as necessary. Now you would dry the flux with a small feathery flame by petting it with that hit and run method while the piece is on the tripod. You should really do that part from above. Once the flux is dry, change the flame to a 1-inch cone flame and heat the piece from underneath in concentric circles until the solder melts. Remember, the tip of the blue flame is the hottest part. It's important to move the flame away from the solder as soon as the solder melts so it doesn't pool in the middle. If this happens, the next step will work, but it's harder to control. Now you would quench the piece with the steel tweezers and then carry it by hand to the pickle area. Place the piece in the pickle with the copper tongs to remove any fire scale from your work. This would be a good point for taking a process photo. Now you'll have both pieces in the soldering area. Flux both pieces and put them on the tripod. As a side note, the reason we solder this way is because if you have a piece with piercings that you are soldering to a larger piece, you want to do it properly. If you take shortcuts on this sample, you won't have practiced the skills you need for later. The larger piece should be fluxed and then placed on the tripod first with the sanded side up. The smaller piece should then be fluxed and should be placed on top of the larger piece with the solder sandwiched between the pieces. Use a feathery flame to dry the flux and then change the flame to a 2-inch cone flame and heat the pieces from beneath until the solder melts. Quench the piece by immersing it in water with a steel tweezers. Then carry the piece by hand over to the pickling area and place the piece in the pickle with the copper tongs. The last step in each process is to clean the work so the instructor can see the solder seam. This also means filing and sanding to ensure no sloppy solder is left. This is a practice for removing solder later on your actual jewelry pieces. Remember, craftsmanship is a part of professionalism, and this practice will help you understand what is expected for finishing actual jewelry pieces. Remember to take process photos and final photos of the solders so you can add them to your digital portfolio. You will need at least 2 images of each type of solder sample, which means you need 8 images total. Once the work is cleaned up, put it in a baggie in your locker until all the pieces are done, and then submit them for credit.